Okay, we're gonna go ahead and get started with introductions and kind of get the ball rolling because we've got a limited amount of time and I feel like we're gonna use a lot of it. So we've got a lot of information to present and we want to make sure there's enough time for Q&A. So just a couple housekeeping things. Please make sure that you are on mute currently. We will have Q&A at the end where we'll open up and you can have the floor to ask questions. But in the meantime, to make sure that everybody can hear, because we're from Illinois to Indiana to Alabama to California. So there's a lot of space between all of us. So we want to make sure that everybody can hear the best that we can. So welcome to our Manufacturing Day celebration. We're really excited to share all of this information with you, and we'll get started. Okay. Okay. All right. Is that better? Okay. All right. I'll get started. My name is Brittany Irwin. I'm administrative assistant here at North American Lighting in the corporate office. And I do just that. I assist anybody with anything relating to North American Lighting. My background is in elementary education. So when I get to use my teacher skills in other settings and promote North American Lighting with students, I like to take advantage of that. So I worked with Kayla to help reach out to the schools and be able to work with all of you today. So.
And my name is Kayla Boyle. I'm the Senior Corporate Branding Specialist. I sit at our corporate office located in Paris, Illinois. And some of the major responsibilities of my role is community outreach for things like this. So I'm excited to be connecting with you all, albeit virtual this year due to the pandemic, but I'm excited for what Dan and Amit have to share with you about manufacturing and automotive technology.
Looks like Amit's having some trouble unmuting. I'll go ahead and go first. I'm Dan Davies. Great to meet you all. I'm the Innovation Manager at North American Lighting. What that means is I look for companies outside of the company that have technologies that we don't have. And we talk about how we can incorporate their knowledge and technology into our processes and our products. And I'm out here in California, in San Francisco. How are you doing, Amit? Might have a stuck mute button. Oh, Amit, do you want to try maybe rejoining? And then we can introduce you. Amit and I have a little section of the presentation that we'd like to share with you today. So when it comes time to do that, maybe you can do your introduction.
Okay. All right, so I'll get us started with a little bit of background. So what is manufacturing? Manufacturing is industrial production of goods using robots, using people, all types of skills. So it's a big deal. And there are so many things that are manufactured in our world today, and the process is evolving daily. So it's very important to the world that we live in currently. And that kind of lends itself to, why does manufacturing get a whole day? Well, we want to make sure that we're involving our entire community. These are the folks that help in our facilities and help us create our products through the manufacturing process. So we want to make sure that we're involving them to show them how important they are, and also get them involved, let them know careers and skills and all the opportunities that we have. And the other bonus is industry-wide collaboration. While we're part of the manufacturing process, we make the headlamps. Well, our headlamps will eventually make their way onto a vehicle, which is also manufactured. And so looking at all the pieces that make one car, there's a lot of different manufacturing processes. So we want to make sure that we are celebrating manufacturing as a whole, because it does take a whole village. Who participates in Manufacturing Day? Our employees. We're here with you today, but we also want to make sure that we are celebrating with our current employees, appreciating them, and applauding them for all their efforts. Then we also want to celebrate with our local families and our local schools, because again, they do make up the community that we are thriving in and that we serve. So it's a big deal that we include our local communities and families and employees in Manufacturing Day. And in the long-term goal is to make sure that we're spreading knowledge and awareness of the manufacturing processes and procedures that we have in our communities, because there is so much unknown, I feel like, at times. I grew up here in Paris, Illinois, and manufacturing was not something that I was really familiar with growing up. And so in my adult life, I'm learning a lot about it, and it's very fascinating. So we want to make sure that we spread that awareness with children, with families, and make sure they know what we do and how exciting it is. And then we also want to work on our recruitment. Like I said, manufacturing is evolving daily, and so are our processes, our skills, everything that we use on a daily basis. So we want to make sure that we are reaching out and getting those young minds who are developing tomorrow's technology to join our team, so we can all work together. So our long-term goal is to get you all involved. So that's just a little bit of Manufacturing Day, and Kayla will give you some more information and history on NAL.
Yeah, so just briefly here, for those of you who may not be familiar with North American Lighting, we are the #1 supplier of exterior automotive lighting in North America. And then our company, Quito, is located in Japan. There we go. Then our parent company, Quito, is located in Japan, and they are the largest exterior automotive lighting supplier in the world. So between the two of them, we've got a pretty big job to do. Our main products that we manufacture, you can see here on the slide, are headlights, taillights, and fog lights. And we manufacture those for major auto brands that you guys are hopefully all familiar with. Some of those being Toyota, Honda, Nissan, GM, Ford, and Subaru. So based on the timeline here on your screen, it looks like we might be glitching just a tad, but it'll come back. We've been around since 1983, since probably all of you, maybe some of those teachers, were born. So that's nearly 40 years of innovation and growth that we've experienced. And you can see all the different plants that we've added since we started in 1983, and all the different expansions that we've experienced. We most recently added a facility in Mattoon, Illinois. But right before that, we had a pretty exciting transition. We transitioned a team, including Amit and Dan, to our Silicon Valley lab in California. And I'm going to let them talk a little bit more about what they do, but they are investing and partnering with startups that have new ideas for the future of automotive technology. Like Dan said, technologies that we don't already have, but that are going to help position us to continue to be leaders in manufacturing and in the automotive industry as things start to change and evolve.
So I think the screen's kind of blurred out for me. Okay, now it's coming back. I didn't get a chance to introduce myself. Sorry, I was having some technical difficulties. Even living in Silicon Valley, it's not the best. But My name is Amit Mehta. I'm the head of innovation for North American Lighting. Basically, what my job is to find the right startups that fit into our core business. And our core business is lighting. Not only do we do automotive lighting, we have about 30% market share of traffic lights and street lights in Japan. And give you an idea of what that really means, if you guys know, Facebook was a startup, Google was a startup, PayPal was a startup, all the big guys, Snapchat, Twitch, everything was a startup. And where Dan and I sit, it all happened. For example, we sit at an accelerator incubator called Plug and Play, and Plug and Play is where Google started, where PayPal started, where Lending Tree, Dropbox, all those things came out of this accelerator. So there's only 2 or 3 people working at that time trying to get this startup going. And then they made it so big that now everybody in the world uses them. And that's what we're trying to do. So we're doing what we're doing now, you'll probably see on vehicles in the next 5 to 10 years. So that's been our goal. We invest in different startups, we bring them into our company, and we do what we do best, which is make it scalable. So to give you an idea of how we've grown in the past, this is kind of a trivia or quiz. So I'm going to quiz Dan, I think is the easiest way to do it. But 20 years ago, lighting didn't really have a face. But now I'm pretty sure if you're driving down the street, you can tell easily what a Lexus looks like, what a BMW looks like, what a Porsche looks like, what a Tesla looks like. And it's all based on lighting. So you can imagine the growth we've seen in the last 10 years. So Dan, let me quiz you and see which one you think is what.
I better get these right.
What is the bottom left, number 3?
Number 3 is a Lexus.
Okay,
RC,
yeah, great.
it's a 350 or 450. 350. I'm gonna go with LC 350.
So close, but that's not the one. That's not it. That's the RX 450 and RX 350. It's the high grade PEZ lens unit. Number 5 is the Lexus LC 500. And that one looks awesome because what lighting has allowed us to do is it can create a face of a vehicle, right? If you're an aggressive person and you like fast driving, you're gonna want a Porsche, and you're gonna want these lights that look like they shoot laser beams at you. So you want this kind of approach that creates this whole unique look, and that's what lighting does. And we're continuing to grow in that area. So another one that we do, how about number 4, Dan?
Number 4 is the Hummer.
The Hummer, yep, that's right.
Oh,
The
missed
new
that one.
electric Hummer is coming back. And I don't know if you guys are old enough to remember, but the Hummer was this huge utility, unnecessary vehicle on the road that had no place to be on the road. It was supposed to be used for military, but they brought it on the road because Arnold Schwarzenegger really liked it. And now it's coming back as an electric vehicle, so it's going to be amazing. And finally, what about number 6, Dan?
I think that's also an LC 500.
That's right. Yeah, that's the LC 500. Sorry, there's a.
Oh.
Okay.
There we are.
That's the LC 500 as well, and you can see it creates that mirror image. Really difficult to do, but really cool looking lighting. So let's talk about where we were before and where we are now. So around 1784, which is way before any of our times, was the first time we had something called a steam engine. And we didn't have too many of them, but they were produced in a mechanized production. That means that you have this line, one guy gives something to another guy, and the other guy gives something to another guy, and they all put this stuff together, and they create this train, and this train's able to transport people and goods. So that created the first industrial revolution. People started going into these areas that had cities and factories to produce these trains. Well, then in 1870, we came up with electricity. And electricity created this whole new level of manufacturing. We were able to mass produce. So actually the first person to have electricity in his house was, and the first investor was JP Morgan of Chase. So Chase Bank, the guy who started Chase Bank, he had his entire house with electricity in Manhattan. So it was the first house, it was amazing. Back now, it just feels like we should all have electricity, which we do, but back then it was just this major innovation, right? Then we got to this point where somebody said, hey, I'm going to use something called computers for increased automation. So I'm going to use the logic or the brain, which is called a transistor, make many different transistors, put them on a chip, and now this thing works as a brain. So we started using computers for automation. And we're in that stage right now too. Everything that's made uses computing. For example, if you want to, when you get to the work, you want to take a vacation, you have to go on the computer, put your vacation in, and then they know that, okay, this person's taking a vacation. If you go to Taco Bell, you order something, it shows up on somebody's screen, they know the exact industrial line of how to make that taco, right? So we're using computers, but it's not super smart yet. Now we're at a place of intelligence. So what's intelligence? I'm sure all of you have heard about AI. I'm sure you heard about crypto and blockchain, quantum computing, virtual reality, biotech, 3D printing, materials. But this all comes from what we would call AI, the ability to have something that's semi-intelligent, has the ability to go onto a brain, like we have a brain. Our brain is basically software and we're the hardware. And as we learn and learn and learn, we become smarter and our brain becomes smarter. And that's how this computer is be able to react. So if you remember the Terminator or iRobot, this computer becomes smarter and smarter and smarter, and it has the ability to make these decisions. So with that manufacturing, what does that mean? It means that if you like Taco Bell, for example, and you come in and every day you order a bean burrito with sour cream, with 1 tablespoon of sour cream, eventually this guy knows that your name's Bob, and he's going to always have your burrito ready for you at 4 p.m. because they have enough data on you to know that this person likes that particular burrito. And that's the same for manufacturing, right? We were just talking about this earlier. There's a big issue with toilet paper at Costco. You can only take 1 toilet paper at Costco from now on. And Costco's wondering, what do we do? Well, the problem is that they don't know what's going on with the ships. It's all backed up. They don't have enough trucks to deliver those to the right stores. So people are not going to get what they want and need. And this all comes from the ability to have AI to optimize what do we need, at what point in time do we need it, and how to personalize it. So let's get to the basic question. What is manufacturing? And the key is, what do manufacturing engineers really do? So they focus on the design and operation of integrated systems for the production of high quality, economically competitive products. And let me break that down for you, what that really means. Let's say that you're 2 guys in a room and you're going to start Facebook. So how do I start Facebook? It's very difficult. I'm going to put it on a piece of paper that my software or intelligence is going to connect 2 people together, and that's my value. So I can connect with Dan, who's sitting in San Francisco right now, even though I'm in 30, 40 miles away. Then you build in the components of it. And if we look at it from a manufacturing standpoint, like Tesla, they would start to build a very rudimentary or very simplistic prototype. So they'd order a few things and they'd see if it works. It would be the ugliest car, but they just want to see if they can go from 0 to 60 in X amount of time, and if they can actually make it safe. Then they start hacking stuff to make it work and bringing it all together. And the manufacturing engineer still hasn't come in the picture yet. They build a prototype. Then they validate that prototype. So they put it on these different tests, see if it actually works. Then finally, they give it to the engineers who say, okay, how do we make this scalable? How do we make millions of Teslas a year? And that's the big question. That's where the manufacturing engineer comes in. And the design engineer that works for manufacturing and the manufacturing engineer work together to make sure that they can make this line of always actuated production, just like Taco Bell. Imagine you went to Taco Bell and said, I want a bean burrito, and they had to go through all these steps and you get it the next day. It wouldn't work for you. You want it immediately within 30 seconds. And this is the process that basically everything that's automated or manufactured has to go through. So this includes, for example, computer networks, robots, machines. All these things have to be manufactured. The screen keeps on changing rainbow colors for me. Okay, now it's back. So examples include automated chemical manufacturing facility through computer integrated technology. This is pretty important for pharmaceuticals especially. Design a circuit board manufacturing process to reduce costs and improve product quality. This is very important. Imagine your Apple iPhones were $4,000 or $5,000. Would you still have an iPhone? Probably not. And that'd be the fault of a manufacturing and design engineer that just didn't know how to optimize the cost. Once again, it's blurred out. So let me see. Not sure if it's okay, it's back. Develop the best assignment of machines and equipment to various manufacturing cells and discrete parts manufacturing. Basically, this large sentence. Are you guys seeing this too? This kind of, okay, I don't know what that is. Okay. So basically that's developing like different cells on an industrial line and connecting them together. So I'm going to go with the Taco Bell example because it's so easy, but you have one guy that puts the beans in the burrito, one guy that puts the rice in the burrito, and one guy puts the sour cream in the burrito, right? But how do you make sure it works all together? What if the guy with the sour cream is ready before the guy with the beans? Then you've just wasted time. So the cells have to match up correctly, and each of those stations are called cell. So the burrito, the bean guy, the sour cream guy, and the cheese guy are all different cells. Develop and implement fabrication processes for nano micro devices. This is just an opportunity now. This is what you could potentially do in the future. You could work with AI, bringing in very minute changes that cause greater optimization of what we're trying to do. And this is probably one of the most important, but identify the most cost-effective material handling. I don't know what this is. Okay, material handling and facility layout alternative for, okay, now it's done. Okay, for an aerospace manufacturing company. That's another example that you could work with SpaceX, you could work with the Boring Company, you could work with Jeff Bezos, I think Blue Origin. You could try to make those all work together and manufacture rockets and go into space. All right.
Great, Amit. Thank you. You know, I'm glad you brought up the toilet paper thing. We were talking about this earlier today. You always think of AI as this robot or machine that's going to cook for you. It's going to clean for you. It'll be a conversation partner. I never thought it would be delivering toilet paper or optimizing toilet paper delivery routes, right? Really cool. Also, I love the comparison of Taco Bell to a manufacturing line. I never thought about Taco Bell in terms of manufacturing, but there's a lot of similar problems that we think about solving, right, when we go to put together a manufacturing process. So we spend a lot of time thinking about what the future of manufacturing is going to look like. In 5-10 years, how are we going to be making products? What products will we be making? What are the new technologies we're going to be using? So the best way to try to understand the future is to first look at what happened in the past. And so that's what we've done here. There's been 4 major industrial revolutions so far throughout history. Amit gave a brief introduction of each of them, but let me go into a little bit of detail about each one and what were the problems that each of these revolutions solved, and then what were some of the problems that were left over that eventually led to the next revolution. So we'll start with Industry 1.0, which is what we call this, is the first industrial revolution, the first time that we went from people building individual products, a lot of it was textiles in the US, to now going to mechanization. And a lot of those use steam power, and that allowed us to power machines, lathes, drill bits. It allows us to do much more with our hands than we were previously. But a steam-powered generator is not really the most powerful or the most efficient engine. And so you see in this picture here, you see these ropes and pulleys up at the top of the shop. This is actually what a shop floor looked like. And there'd be belts connected to each of these wheels and a transmission system, a manually controllable transmission system. And you'd have to transfer the power just to the machine you want to use at the time. You wouldn't be able to run all of your machines all the time. So you're still kind of limited in how many parts you can make and how quickly you can make them. So that changed with the electric motor. Now you've got this electric powered machine that you can put as many as you want in here. I've got a picture here of a factory that looks like it's got hundreds of them. And now you can start making multiple parts in parallel. You can run all your machines at the same time. But these still had tough working conditions and still relied a lot on manual labor. You're powering a drill bit, but somebody still has to use the drill bit. So there's always, for every process, for every machine, there's still a person manning it. And it wasn't safe. Injuries were commonplace. And these were problems that needed to be solved. So we come to Industry 3.0. This is the first time robots started being used. And the automotive industry is one of the first industries to start adopting robots for production because it solved a lot of the problems that we saw in Industry 2.0. Worker safety was one of them. Robots can't get hurt. They can break, but you can just fix them. And we have less dependence on people. So that means we can start running our production facilities for longer hours. We worry less about fatigue for people. And we can really augment our workforce. Maybe one person can oversee 2 or 3 robots. So now one person is producing the output of previously what we had from 3 or 4 people. But we still need a lot of thinkers in the plant, right? These robots are designed for physical manual labor, and that's great because we can save our hands, but the human brain is still behind everything. And so people still need to make decisions. And we're really good at making a lot of decisions, but there's a lot of decisions that are more complex. Let's talk about the Costco toilet paper problem again. There are so many streets and so many Costco buildings and so many toilet paper inventories. It'd be really hard for people to work out these routes and especially do it quickly. So we can't process that much information. So then we get to Industry 4.0, and now we start talking about the AI solutions, the quantum computing solutions, the machine learning solutions. Now machines can take these huge sets of data, analyze it, process it really quickly, and make decisions for us. So that's really cool. This is the first time machines are taking the extra step from physical labor to now doing the thinking for us. But we're still early stage. Data sets are not optimized. We waste a lot of time looking at data that maybe doesn't matter, or it's the wrong data, or it's in the wrong format. There's a lot of trial and error in AI. It's not as glamorous as it looks like in the movies. There's so much trying things and failing that goes on as well. And really, they're thinking machines, but they don't really think. They think what we tell them to think. They're still really under our control and in that sense doing still a limited amount of the thinking. And we still have a lot of process engineers that are behind these decision-making machines. So I think the next step going towards the future is we're going to be giving more and more responsibility to these machines to go further in what they're thinking about, what decisions they can be responsible for, and even start maybe generating new ideas for us to consider.
Thanks, Dan. Great intro. So let's talk a little bit about lighting, just to give you a history lesson, since it is one of Paris, Illinois' major industries. So lighting basically started in the 1800s when you would take basically a candle, light it up, and put it as your headlight. And then when it went out, you just light another candle. That didn't work very well, as you know. And we got to the point where Cueto started around early 1900s in 1915. And then we started seeing opportunity to add more lighting to vehicles. In the 1980s and 2000s, we saw a little bit more styling around the lighting, but nothing major. The breakthrough happened in the 2000s, in the present, and what we're seeing in the future is how are we going to put lasers and sensors into our lighting? But our mission has always been the same thing. We wanted to lead continuous improvement in global roadway safety through innovative lighting and mobility solutions. We've done that. We've done that for the last 100 years. But we've now seen an opportunity to take what we have and use branding. As I said, that Porsche that comes down the road, that Tesla that comes down the road, that Ferrari that comes down the road at night, the only way for you to recognize it is through the lighting. So we found an ability to take branding and encapsulate everything that we've done in the past as safety and branding into one unit. And now we're looking at ways to put the same sensors and lasers into our lighting for the future. So you can see each of these sections requires manufacturing engineering because it requires a new optimization. I'm going to keep going back to the Taco Bell example because it's so easy, but let's say if you have a bean burrito and now some guy wants a 7-layer beef burrito. Well, that requires new manufacturing line because you can't have the same people who are doing the beef burrito on the same 3-person line doing a 7-8-person line, right? So you'd have to make a larger line for that same burrito to be used or have the accessibility to the ingredients. Same thing with lighting. You have to have different cells or different manufacturing lines to make different lighting work. And that's inspired our vision, right? So we're inspiring the world to see more through safe and sustainable integrated lighting and sensing mobility solutions. We're gonna need manufacturing engineering to make each of these steps work. There's not gonna be a need for manufacturing engineers. So if you want a safe career, it's something you should really consider. Next slide, please. And this is a good thing to look at here. So imagine this car in the center here. It's a Lexus in the middle of San Francisco driving autonomously. There's nobody inside driving that car. And there's a pink umbrella to the side. There's a guy on a bike that's literally a foot away from the car. There's a train in the front. There's a Bud Light beer truck in the front as well. Someone's crossing the street. You and I make these decisions pretty easily, right? We're looking at this, okay, don't hit the guy on the bike, so I'm not gonna go to the right. I see a red light up there, so I'm gonna stop. That person is crossing the sidewalk, so I'm gonna stop. I don't wanna hit her, and I don't wanna swerve into that Bud Light. My brain is the software. It's able to make all that work. But what is required to make that vehicle work? At least not autonomously, but as a vehicle. So the first thing is optical engineers, which NAL has a lot of. And the optical engineers make use of optics to solve problems and design and build devices that make light do something useful. So you can see the light there is the brake light. You and I all know that that means stop. It's ingrained in our head to know that that vehicle is stopped and we should stop as well. What's a mechatronic engineer do? So there's a sensor on the back there that's connected to the vehicle. They use mechanical, electrical, and computer and software skills to work with smart technologies such as robots, automated guided systems, and computer integrated manufacturing equipment. They're really putting together the mechanical portions and the electrical portions of the vehicle. Now, what about the brains of the vehicle? So those are the software engineers. They develop, design, and test software applications using C++, Java, Python, and others for cloud, mobile apps, etc. And you can see all of this has multiple applications. It's not just for manufacturing. It could be used for finance. It can be used for healthcare. Everything requires these engineers to come in and kind of make it work. Then there's the system engineers. They have to analyze the system challenges, identify the best solutions to meet the project needs. There's a lot of challenges right on there, right? It's raining. There's a guy on a bike. As I said, there's the car is stopped, don't turn left sign. There's so many issues with this picture, but you and I can make decisions very quickly to not hit people around us. And finally, the automotive engineers, they design and test braking systems, engines, fuel technologies, and transmissions within a vehicle. That's going to change soon because we're moving to electric vehicles, but the point is that they make it work as a vehicle. But for all of this to work, it has to be at a reasonable price. So it has to be produced very cost effectively. As I said before, you wouldn't buy a burrito that costs $1,000. You wouldn't buy an iPhone that costs $5,000. It's just not logical. So they have to find the right price point that makes it work for the consumer. And the guy that really does that to make it put it all together is the manufacturing engineer. Even though the optical engineers, the mechatronics, software engineers, system engineers, and automotive engineers are putting stuff together, they don't know how to make millions and millions of them at a low cost and high volume. And with that, the manufacturing engineer makes it safe. That's number one. They can make it mass produced and cost effective. They automate it, just like we talked about the Taco Bell line. And eventually, they're going to start using AI to get the data from the sensors that make this vehicle better or make Bob get his burrito right on time when he comes in at 4 p.m. Next slide, please.
All right, thanks, Amit. You're making me hungry for Taco Bell. It's almost lunchtime here. Let's talk about what manufacturing companies like us need. What are the core competencies and skill sets that we need? So right now, here's what NAL is good at. We know material science very well, plastics. Quality engineer, this guy with the yellow hat, is inspecting a part. We have lots of processes like this, inspections. We have process engineering and material handling. This is kind of similar to the Costco toilet paper problem, but we have all of our parts in the warehouse, and all those parts need to get to each cell that Amit was talking about, whether they make a bean burrito or a 7-layer beef burrito. The parts need to get right on time, and they can't come too early either because we don't have space to just pile up a bunch of parts. So not something a lot of people think about, but where you keep your materials and when and how you move them around is actually a really important problem. And we have people working on that problem. So going forward, what are we going to be looking for? We need a very high competence in semiconductors. More and more chips are going to headlights. More and more factory automation is requiring very high level processing. We're going to need software. Every semiconductor chip has software on it and firmware. So that's going to be an important skill. And then one step beyond that is data science. This is kind of where AI and machine learning fall into as well. But handling large amounts of data is a particular specialty of software engineering, and it's a particular type of software engineer that handles that. And then finally, communications. With more machines coming into the factories, they're also starting to communicate with each other, not just with the people that are managing them, but they exchange data among themselves as well, so that your whole factory kind of gets this one connected, presence. All the data can go to one spot so that we can handle it from a central server. Okay, so let's talk about developing these competencies and how we do that. So you may have heard the term R&D. A lot of companies use this term. So what really does it mean and why is it important? It stands for research and development. And when we transition from those core competencies we have today to software and semiconductors and those skills we're going to need tomorrow, there's a lot of research and development that happens before that. And it can take a long time. That's why we really try to think about what's going to happen in the future and what we're going to need and get started now to develop those skills. So we have our current products. You can see in the lower left of this square chart I have here, our current products, headlamps and tail lamps. And I don't know if you guys knew, but we also make street lights and traffic lights in Japan. So lots of infrastructure lighting as well. Now going forward, there's going to be more and more sensors coming into the headlamps, tail lamps, traffic lights. Those sensors are things like cameras, radar. You've probably heard of those. LiDAR is this kind of newer technology that uses light, sort of like a radar, but it uses light to measure distance. And a lot of vehicles and infrastructure lighting are going to have these sensors integrated into them. And so now producing these sensors brings up a lot of new needs as far as know-how. We have to understand the chips that go into these sensors. What does a photosensitive sensor look like, and how do we need to handle that in a manufacturing environment? Then we can take that a step further and say, well, there's also going to be a lot of data coming off these sensors. Now we need things like machine learning to analyze that data. There's also things like in-vehicle monitoring that includes facial recognition to look at the driver, make sure the driver's staying awake, not too drunk, things like that. So looking into the future, in order to prepare to build those products, we need to first develop the technology and the know-how to manufacture those. And so that's the role that research and development plays. All right, so that we're coming to the end of our presentation now. I just want to tell you all that we are always looking for new talent and looking for new people to join our team. And you know, Ahmed and I have a podcast. It's called Mobility Now. And what we do on this podcast is we interview people who are knowledgeable and experienced in the world of mobility. That's everything from self-driving cars to drones to even things like DoorDash and Uber. And we always ask them at the end, you know, what's your advice for people who are just starting out, maybe just graduating, looking for their first career, or just wanted to get involved in the automotive industry? And they really always tell us the same thing. It's that you might have a specialty, whether you're a software engineer or a process engineer or even a salesperson. But what you're going to really need more and more is a broad understanding of lots of different fields. So, and it's because all these fields are starting to come together. So you might need to have some basic understanding of data science. You might need to have some basic understanding of the Internet of Things, right? Kind of like to go back to this Taco Bell example, more and more, everybody behind the counter has to have at least some working knowledge of everything else that's going on because they're becoming more and more connected. So the advice is never stop learning, always be curious, and try to learn as much as you can about fields that might not be your specific specialty, because in the future, more than likely, it's going to serve you well.
Awesome. Thanks, Dan and Amit, for sharing your wealth of knowledge with us. I'm sure many of you listening have some burning questions that you would like to ask of Dan or Amit, or even of myself or Brittany. So now is the time. If you have a question, you can unmute yourself to ask that question, or write it in the chat box and we can read those. If we don't have any questions from the floor, some were submitted when you guys registered, so I have a list that we can run through. But first, I just want to open it up for some live Q&A. Well, let me go ahead and kick us off then, so while you guys are still thinking of your questions. Anyone can take this from our team here in NAL. But the first question is, what education is needed for manufacturing engineering?
I'll go ahead and jump in on this one. And it comes to education, there's so many different levels that can apply themselves nicely. To start working right out of high school, we have positions where you can jump right in and start learning manufacturing from being an operator on up. If you want to start in college and choose a field of an engineering field of sorts, you can do that and then come on board after you graduate. We also have apprenticeship programs where you can go to school and work at the same time simultaneously. So you're getting your work experience along with your education, and then that kind of helps you navigate to the direction and the field that you want to specifically study. We also have tuition assistance programs. So if you start working and you decide you want to go to school to change your field or learn more about something to become more of an expert in that field, we do offer tuition assistance programs also. And also looking at different opportunities. Like I said before, my previous background was in education, but when I joined the NAL team, I am able to use those same skill sets in a plethora of different settings within our corporate office. So while I may not be an operator on the line, a lot of what I do behind the scenes in our MRP operating system and things, I can do my part to help, and it's all growth from my previous experience and skills. So there are a lot of opportunities in a lot of different directions. And education can have many faces here because we do a lot of in-house education and training too. So education is very important, and there are a lot of different means of utilizing your education.
Thank you, Brittany. Another question that came in, we talked a lot about software and software intelligence. Do I have to know a lot about software to be a manufacturing engineer?
You want to take that, Dan?
Sure, I can take that one. So it depends what you want to do. Certainly, there are positions within manufacturing that are heavily software focused. You might even be doing some coding. And for that kind of position, yes, you do need to be an expert coder. You need to be pretty good at what you do. But, right now, most of the positions aren't that software development intensive. You might be using software, but in the same way, you don't need to know every working detail of an engine to drive a car. You just need to know enough to use it as a tool. And so going back to the advice that our podcast hosts always give us, learn a little bit about everything and have a good working knowledge about it. I recommend that for software as well. You don't have to be a master coder, but if you understand some of the basics about what languages are out there, how they're used, what are some of the capabilities of coding, that will help you really be an important part of a cross-functional company like North American Lighting. You'll probably be talking to software engineers. So being able to at least speak the language is going to be really beneficial and will give you a leg up in your career.
Thanks, Dan. Our next question is, can you give an example of the day-to-day life of a manufacturing engineer?
Want to take that one, Dan?
Sure. So I am not a manufacturing engineer, so I haven't lived the life, but I have talked to a lot of them and I see them on the manufacturing floor sometimes. And I'll try to answer it. Well, there's really not a daily schedule that they do every day. It really depends on what's going on. But if there's ever some kind of issue, a machine breaks down or there's a material shortage, something's gone wrong that we can't make the parts that we are planned to make every day, that would be their focus. So they need to have this broad skill set to be able to handle any kind of problem that could come up and be able to address it quickly. So there's a lot of experience that goes into that. So they might spend a part of their day addressing some of these issues and making sure that our machines are running properly. All the production lines have the people and the tools and the skills necessary to make the products for that day. And in the end, make the number of parts at the quality that's expected of the day. So I guess I didn't give you any good detailed specifics, but that's their focus for the day.
Sounds like they have busy jobs.
They're always busy, that's for sure. I can't find time to talk to them very often because they've got a lot going on.
Let's see, our next question asks, what kind of soft skills are considered valuable to you as an employer? And I might jump in, and then if anybody has anything to add. So soft skills are those skills that aren't usually taught, but they're really important in a professional setting. They're going to be skills that help you interact and work well with others. So from personal experience and working here at North American Lighting, some of the soft skills that we find valuable is the ability to communicate verbally between your peers, your supervisors, and even leadership to clearly express your new ideas or suggestions or even some problems or concerns that you're having so that you can solve them together as groups. Other soft skills that are important, time management. This is important so that you can organize the structure of your day to be productive and stay on task. So in the professional setting, there's not a lot of hand-holding that goes on, and there's no extra credit that can be given to make up for late or missed deadlines. So if you miss a deadline, if one person even just misses a deadline, that has a ripple effect onto the whole cycle of manufacturing, and it disturbs our production. So meeting deadlines is really important. being able to stay on task and be kind of a self-motivator is important, one of those really important soft skills. And then one other I'll throw in before I ask for any other ideas from this group is being able to manage and understand your own emotions. So some emotional intelligence there, keep a positive attitude so that you can work well with your team members.
Yeah, for me, for myself, the most important soft skill is when I'm looking to hire somebody or interview somebody. There's only two. Number one is, do they know how to ask the right questions? So whenever you start your career, there's going to be a lot of issues and challenges that come up. And the guys who ask the questions that get people stumped, those are the guys you want hanging around, because those are the ways to fix the issues that you have. And number two is the people that can take something very complex, such as AI or semiconductors or even manufacturing, using Taco Bell as an example, and explain it very simply. So we call that framework. Somebody who can do that. So those are the two soft skills we really look for when we hire in this area.
Being an innovation manager, I also have to throw out being innovative and creative. Those people that can think of new ideas and bring them to the team, those people are very valuable for us. So not just people who are told what to do and they do it. It's really important to have your own ideas and be thinking on your own and being creative.
I'll also jump in on this. Two things I've learned in my experience in my few years here is to be culturally aware, know your surroundings, and know who you're speaking to and how to speak to them, and things like that in the appropriate professional tone. And something else is humbling yourself. I cannot count the number of times I've made a mistake and I have said, this is my fault. I will fix it. And then I learn from it. So just making sure that, we are people and we do make mistakes, but you own it and you learn from it and then you move on and then you just continue to make it better and grow professionally.
Sounds like there should be a degree on soft skills. A lot of advice here.
Absolutely. We'll take a break here. I've got a couple more that were sent in, but does anyone have anything that's come to mind that you would like to ask? All right, a couple more. Dan or Amit, what kinds of classes should I be taking in high school or college to prepare me for this kind of a career?
Yeah, maybe I can answer that. So I'm going to go back to saying it depends what you want to do, right? But really, do what interests you. That would be my advice. It's really important to have an interest and a passion in what you're working on. So what's more important than trying to predict what's going to be the most needed or the most important and then trying to study that? It's probably better for you to pick something that you really enjoy doing. And there's probably a way to utilize that in a manufacturing company. Also, I'll say that what you're doing in high school, no matter what you study, is developing you for a good career in manufacturing. High school, it was really exciting for me because it's the first time that you start to use your creativity. You start to learn how to collaborate with others, communicate, do research. All those skills are not a particular subject. It's just things that you learn as you go through your studies. And those are really, in the end, what counts. And as long as you have those skills solid, you can study a lot of different fields and still be successful.
Okay, thank you very much. I believe we are about out of time, so we will end there. I do have a couple questions in the chat, and I will get those answered and then send an email out. And if you have any other questions, or students, if you have any questions, you can always reach out on our social media for NAL Inc. on Instagram and send a direct message, or DM as the kids say these days. Kayla will be able to help us with that. So if you ever have any questions, please don't hesitate to reach out. We appreciate everybody joining us today to celebrate Manufacturing Day. We hope that we have provided some good foundational information to help you plan a career in manufacturing if that's what you're interested in. And I believe that is all we have. So thank you very much. We hope you enjoy the rest of your day.
Thank you. Bye-bye, guys.
Thanks,
Thank you, everyone.